All right, you guys, today we're going to be learning about how to determine the domain and range of a linear function. So remember, domain is our x values and range is our y values. So when we're looking at our coordinate plane, in order to determine domain, I would want to look at this x-axis to see all of the possibilities. So this would be my domain. And then for my range, I would want to look at the y-axis to see all of the possibilities. So again, this y-axis is my range. And when we find domain and range, we're going to determine it for real-world situations. So that's going to be our story problems, our word problems. It says both continuous and discrete. Continuous are things that we measure, so data that's measured. That's going to be things like time, distance, speed. And then discrete are things that we count. So when we look for domain and range of a continuous function, so something that looks like this, or this, notice it's connected, our domain and range will be an inequality. But when our data is counted and it's discrete, so things like number of books, number of pencils, number of people, that's going to look like a scatter plot. And for this, our domain and range is just a list of numbers. So guys, to review what we're talking about, we're determining our domain and range of linear functions in mathematical problems, and we're determining our reasonable domain and range for real-world situations, both continuous and discrete, and then we're going to represent it using inequalities or lists of numbers. All right, so let's go ahead and look at our next problem. All right, so we have a part of a linear function that is graphed on our grid or our coordinate plane. And we want to know what is the domain and the range of this function. Right off the bat, I notice that this graph is connected. So I'm just going to make a star that says this is continuous. And so first, I'm going to look at my domain, which I know is x. And so my minimum point right here, farthest to the left on my x-axis, well, if I look up, that has an x value of -7. So the minimum x value is -7. When I look at the maximum point, or the farthest to the right on x, and I find its value, its maximum is 6. And notice before I colored in those points, both of them were shaded in. So that means that I do have a point at -7 for x, and I do have a point at 6 for x. So when I do my domain and range as an inequality, it will be x, and x has to be greater than or equal to whatever the minimum is, and then x has to be less than or equal to whatever the maximum is. So my minimum is -7, so -7 has to be less than or equal to x, which is less than or equal to my maximum of 6. Right. Next, we'll look at our range, which is y. So now we're going to be looking at our y-axis. We're going to be looking at our y-axis. keeping in mind that our range for y, when we look at our minimum, that's going to be the one that's farthest down. So our minimum is at a -4. And then our maximum y value is going to be the point that has the highest y value. So I go up, up, up. I see that this point right here has the highest. So my maximum is 4. And again, they are colored in dots, which means they are also solutions. So -4, my minimum, must be less than or equal to y, which is less than or equal to my maximum of 4. Guys, keep in mind that I changed the variable in the inside of my compound inequality because I was now talking about range. So when I look at the answer choices, I see domain is incorrect right off the bat because it doesn't have the also equal to. So I can get rid of F. For domain on letter G, I see that the numbers are correct, but the signs are incorrect. So I'm going to make sure that I cross that off too. For H, domain is -4. Well, my domain's minimum here was -7, so this is incorrect. Which leaves us with G, or our correct answer, J, which is our correct answer. And I do want to take a moment to point out that this G of X right here, that represents the same thing as what an output is, or what your Y is. So saying -4 is less than or equal to Y, which is less than or equal to 4, is the same thing as saying -4 is less than or equal to G of X, which is less than or equal to 4. All right, guys, let's look at the next one. So which graph best represents a function with a domain? So remember, domain is our X value of all real numbers less than or equal to 6. So from that, I'm seeing that I want to know which graph has X values that are less than or equal to 6. Well, I look at my X-axis for both of them. And on answer choice A, I see that it has X values 4, 6, and then all the way down. And this arrow tells me it goes on forever. So here, this does have values of X that are less than or equal to 6. And when I look at B, I see that the minimum value is -4, and it's increasing forever and ever. So my domain here would be X is greater than or equal to -4, which is not what we want. So our correct answer choice would be A. All right, our third example, what are the domain and range of f of x is equal to -37? Guys, keep in mind in our original conversation that this f of x is the same as saying my output or my y. So f of x equals -37 is the same as saying y equals -37. And this is an equation, so it tells me I have a constant value for y at -37. So what that would look like on the coordinate plane is a horizontal line through -37. So every single point along this line has that range of -37. So it wants the domain and range. So we already talked about the range being a constant of -37. But when we look at our domain, these arrows tell me it goes forever to the left and forever to the right, which means along my x-axis, I have points for every single possible value. So this is where we get all real numbers. So A is not correct because my range is not all real numbers, and I don't have a limitation on my domain. B is an easy, silly mistake. Do you see how they flipped our domain and range? C, domain is all real numbers. That checks out. And then range is all real numbers greater than or equal to negative 37. This is not correct. Domain here, all real numbers, is correct. And we have our range of just negative 37. So here is our answer choice. All right, guys, that's it for domain and range. I hope you've taken something away. Enjoy.